Okay,
pi squared
we
over
got an interesting differential
6.
equation. This is given to be as dy over dx is equal to 6 times y squared x with the boundary condition that y of 1 is equal to 1 over 25. So the meaning is when x takes the value 1, the function takes the value as 1 over 25. Now what is the requirement? See, we've been given this, right? Given that dy over dx is equal to 6 times y squared x. Now the understanding is y has changed, the function y. So in this case we are talking about the function, and that is y. Y has changed to give us 6 times y squared into x. Now y has changed because of what? Because x changed. You follow me? Now take this illustration. For example, now you are buying a car, right? It's a new car. Now as you are using this car for 1 year, next 2 years, and then 3 years and 4 years, so when the time has changed from t is equal to 0 to t is equal to say 4 years, you would want to know what is the change that has impacted the car. In other words, in colloquial term we will say the wear and tear, right? The wear and tear, what has happened to the vehicle, right? Suppose you want to sell the car out. People would like to know, look, you have driven the car for 4 years, we would want to know what is the wear and tear that the car has taken. So based on that, the value, the original value of the car would depreciate or would go down, right? So that is how we actually relate differential equations with, because differential equations have got enormous amount of applications. So this is a simple way to understand what we are trying to do here. So we want to know what is the function started with. So originally how the car looked like, right? So that's that would be the understanding that people would like to have before they would buy this car. Okay, so much so for that. Now what I want to do is I would have to find that function. I need to find that function. So I have that in mind. So whenever we are doing differential equations, we will have to relate the differential equation to the practical application of real-time things. So that's the reason I brought in this illustration. So now what I'm going to do is I have to solve this. So if I solve this, if I were to solve this, I will be able to get that original function y. That is the first stage. Now after that I will explain to you what this boundary condition means. Okay, now since we are given this, let me consider dy over dx to be equal to 6 times y squared x. Now we are utilizing variable separable method. Now this is a technique used to solve differential equation. One of the techniques. There are several techniques. So I would be pushing actually y squared down. So if I push y squared down, I would get dy over y squared is equal to push this dx to the other side. So it's going to be 6 times x times dx. So you got that variables, y on this side, x on that side. That's the usual way we write it. Now what we do, we integrate. Now this is rewritten as y raised to the power of negative 2, push it to the numerator, times dy is equal to 6 times integral x dx. Always have the habit of integrating left side and right side at the same time. If I were to integrate this, this is y raised to the power of negative 2 positive 1 divided by negative 2 positive 1 is equal to 6 times x squared divided by 2 plus arbitrary constant c. Now this can be rewritten as y raised to the power of negative 1 divided by negative 1 is equal to 3 times x squared positive c. Now further rewriting is going to be negative 1 over y is equal to 3 times x squared positive c. This is what we have got. Now this is not complete, because we need to know the value of C constant. This is an arbitrary constant, but arbitrary constant play a vital role. So if you are giving this solution without the presence of arbitrary constant, outrightly some of the professors will simply mark it wrong. So this is mandatory. So having mentioned that, how am I going to obtain the value of C? For that, go back to the question. The question gives us y of 1 is equal to 1 over 25. So what it means, when x takes the value 1, the function takes the value 1 over 25. So I'm going to utilize that. So when x is equal to 1, the value of y is 1 over 25. Substitute that. So this is going to be, in place of y, I'm going to substitute 1 over 25 is equal to 3 times of 1, positive C. We need C, right? So therefore I'm writing C to be equal to 3. Push this to the other end. In fact, you can flip this, it will become negative 25. It goes to the other side, it become positive 25. So therefore C is equal to 28. Now take this and put it here. Let me take this as equation 2. So therefore I can rewrite 2 to be as negative 1 over y is equal to 3 times x squared positive 28. We'll just multiply both sides by negative 1. So in that case I would get positive 1 over y. This is going to be equal to negative 3 times x squared negative 28. 1 over, push this down to the left side. So it's going to be negative 3 times x squared. I got this because of the fact that I'm multiplying both sides by negative 1. So it's going to be positive 1 over y, and this is going to be negative 3x squared negative 28. So that's the reason I've got this. So you push it down, you get negative 3x squared negative 28 is equal to, push this up, you get y. So this is what you have got. So y is equal to this. In fact, this is the required function. Now we are actually asked to check the validity of this function. So it says determine the interval of validity. So that means we need to know when the function will vanish, and we need to avoid that. We have got y is equal to 1 over negative 3 times x squared negative 28. Now I want to know when the function will vanish. So for that, just take negative 3 times x squared negative 28 is equal to 0. So negative 3 times x squared is equal to 28, and then x squared is equal to 28 divided by 3 with a negative sign. So this is what I have got. Now in this case you see that x squared is equal to 28 over negative 3. So that would mean, clearly we know that x squared cannot be negative, right? So that would mean there doesn't exist a real number that can make the denominator to be equal to 0, because if the denominator is 0, the function vanishes. So we want to avoid that. So what it means, so this would mean the domain of the function is all real numbers, or you can just place a comma and say x element of all real numbers. Okay, I hope you got this all important information about locating the domain.